Good day, viewers. This is Afia Johnson, your chemistry tutor and your biology tutor. Please don't forget to share this video, to like and to subscribe. So and don't forget our physical lectures for post-UME, WAEC, NECO, JAM and School of Nursing entrance examination. That we have started in Christ Rock Academy, Kilometer 8, Sample Road at Total Junction, 5 to 7:30 p.m. The environment is conducive. There is 24 hours power. Now, we want to start with Diastereoisomerism in chemistry. Diastereoisomerism. Now, we say this is the occurrence of two or more than two organic compounds with the same molecular and structural formula, but without mirror images. So you don't have mirror images. Now, there are three types of diastereoisomerism. We have one, we have epimerism. Two, we have anomerism. And three, we have mesoform compounds. Now let's look at the first one, epimerism. When we're talking about epimerism, this is the occurrence of two or more than two organic compounds with the same molecular and structural formula, but difference in the arrangement of molecules around a non-anomeric carbon atom in their molecules. Now, what do I mean? Let's take a look at glucose. 2, 3, 4, 5, 6. So what you have here is D-glucose. D-glucose is what you have here. Then the second one, 2, 3, 4, 5, 6. Now you have OH here, you have H, and OH. So what you have here is D-galactose. Now let's check. You will see that from this side, what they are the same here. This one has CH2OH, this one has CH2OH at carbon number 6. Now, this is At carbon number 5 now, they are similar. This one has OH at this side, H at the back. This one also has OH in the front, H at the back. Then let's look at this carbon number 4. They are different. That is where the difference lies. They are different. Look at the carbon atom here. OH is in the front, H is at the back. But here, H is in the front, OH is at the back. That's the only place they are different. So the arrangement of molecules, that is OH and H, around these carbons are non-anomeric. What I mean by that, when I get to anumerism, I will talk about that. But look at here, they are similar. This one has H in the front, OH at the back, OH at the back. Then these ones, they are similar. You have OH here, OH here, H at the back, H at the back. Then both of them have CHO. So they are only different at carbon number 4. This 1, 2, 3, 4, 5, and 6. So they differ. So we now say D-glucose and D-galactose, which differ only in the configuration of molecules around carbon number 4 of their molecules are called epimers of each other. So they are epimers. Glucose and galactose now are epimers of each other. Now let's look at anumerism. Anumerism. When we're talking about anumerism is the occurrence of only two organic compounds. Occurrence of two organic compounds with the same molecular and structural formula. They have the same molecular and the same structural formula, but difference in the arrangement of atoms around their anomeric carbon. You can see the difference between anomeric carbon atom, what is anomeric carbon atom? Which is the carbon atom, the central carbon atom, of their hemiketer or hemiacetal group, or hemiacetal group. So if you want to understand that, go and watch the video where we have pyranose and furanose formation. So that is where we talk about mutual rotation. Then you understand what is hemiketer and hemiacetal. Then I can try to see what I can do to shed more light on that with this example I want to give. Now let's look at glucose D, CH2OH. Okay, we have done this one before. So we have OH and H. Now this is alpha D glucopyranose. Alpha D glucopyranose. Do you know that you can have something like this? CH2OH. Okay. Now, in this place, the H is up and the OH is down. When the H is up, OH is down, at this carbon atom is called anomeric carbon, is alpha. But when it is the opposite is the case, you have this compound is what? Is beta D glucopyrranose. So the two of them are anomers because they only differ at the arrangement of carbon around carbon number 1 here, which is the anomeric carbon atoms. Then what are mesoform compounds? Mesoform compounds. A mesoform compound is a compound that has one line, a line of symmetry in its molecule. What that means? This means that the compound can only be divided into two equal and similar halves at only one plane. And as such a compound is said to be bilaterally symmetrical. So such a compound is said to be bilaterally symmetrical. Example is tartaric acid. Tartaric acid. Tartaric acid is COOH, 1, 2, another COOH. Then you have OH, OH, H, H. This is tartaric acid. This compound, the line of symmetry now will be here. This is a line of symmetry. So at this line, you will see that everything that is here up is the same thing that is down. COH is up, COH is down, CHH, COHH, COHH. So that is a mesoform compound. So then the next thing to look at is geometric isomerism. Now this is the occurrence of two organic compounds with the same molecular and structural formula. They have the same molecular formula, they still have the same structural formula. You know that is the property of all stereometric isomers. So, and structural formula, where are they now different? But different position of two similar higher groups around two adjacent carbon atoms, separated or connected by a double bond, a double covalent bond in their what? In their molecules. So that is that. Now, there are two isomers. There are two isomers of geometric isomerism. What are they? We have, these are, one, we have cis geometric isomer. And number two, we have trans geometric isomer. Now, in the case of cis, now in this case, the two similar ion groups are located at the same side. They are located at the same side. They are located at the same side of the two adjacent carbon atoms connected by a double covalent bond. Now let's look at example. Examples are, number one, we have cis 1,2 dichloroethene. Cis 1,2 dichloroethene, which you can have as this. The two ion groups now are chlorine atoms. So 1, 2. So it's either you have it as this or you have it as this. They can be down. So the two ion groups are on the same side, either up or down. Then number two example here is cis but 2 in. Cis but 2 in. You have something like this. CH3 here, CH3 here, H here, H here, or you can have it as this. The CH3, the two ion groups can be down here. Then you have H here, you have H here. So now you will see that the two ion groups are CH3, 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 CH3. They are on the same side of these two adjacent carbon atoms up. Here, they can also be on the same side on the two adjacent carbon atoms at the lower side. Then another example, apart from that, another example, number 3, is cis butynedioic acid. Cis butynedioic acid. So that one you can have something like this. HOOC. There's a double bond here. Hydrogen. HOOC. Then you have hydrogen. Or COOH. COOH. Hydrogen and hydrogen. So you will see that the two ion groups here are COOH. COOH, COOH. So these two OH are on the, they are either here in the front here or they are at the back here. So now let's now look at trans geometric isomers. Trans geometric isomers. Now, in this case, the two similar ion groups are located on opposite side of, they are located on opposite side